Hello, everyone, and welcome. My name is Stuart DeCew. I'm the Executive Director of the Yale Center for Business and the Environment, a joint initiative between the School of Management and the School of the Environment, and the host of the Sustainable Venture Prize at Yale. And today we're thrilled to have the winners of the 2023 Sustainable Venture Prize with us to talk a bit about their experiences, their journey as entrepreneurs, as innovators, what they're looking to change, what industries they're looking to transform, how they're going to go about it. And we're just really jazzed that they're here with us, that they're taking a path at Yale that is one that more and more people are taking, but it really takes a lot of courage, bravery, and a good amount of grit and persistence to do. So we're psyched that more students are looking at this path and engaging on it. And we love to sort of dive into what your inspiration was to go down it, how you're thinking about pursuing it, and all the details. But congrats again. And just first, can you all introduce yourselves and just tell us a little bit about General Biological? You've sat down with your grandma and grandpa, you're trying to explain exactly why you won the 2023 Sustainable Venture Prize and what it is that you're doing. What are you building? And how are you going about it?
Sure. I'm Abhi.
I'm David.
And GB General Biological is essentially a industrial biotechnology company which makes chemicals. In a nutshell, we aim to make the same chemicals that are in the stuff literally all around you, from renewable carbon sources such as sugars and corn scraps and waste streams, instead of non-renewable carbon sources like oil. And the way we go about that is by not using traditional chemistry, but novel biology and biotechnology.
Yeah, and I guess there's been a huge push to making industries sustainable and to decarbonize them. And chemistry is really hard to do because the whole input is oil. All the chemistry you have to do to the oil is super energy intensive. You have to heat it up, you have to move it around, and so the chemicals industry, although it's a very large emitter of CO2, seems to have been sort of forgotten about compared to initiatives in energy and transportation. And so we felt that this was a huge problem that needed to be addressed, and felt that biology was one of the only ways that we could go about making a sustainable chemicals industry that would enable us to continue making all of the molecules that fuel the modern world.
It's great. So it's a big, ambitious idea that kind of requires a lot. It's going to just, if successful, would disrupt a lot of different industries and established players. So you're sitting, at Yale in your dorm rooms, in labs, or wandering around outside or working at an internship. What gave you the idea to start this? What's the genesis of saying this is something that we would want to take on and dedicate, all of our time and energy to? Where did that come from?
Yeah. Well, we kind of started out being interested in industrial biotechnology, interested in biomanufacturing, aware of this problem in the chemicals industry, and this being a solution that was viable but hadn't been successful so far. And so we sort of all sat together and tried to figure out what is the obstacle? Why has biology not been successful in chemicals manufacturing? And we started out thinking we would do B2B services, essentially optimizing bioprocess, because we figured that this is too expensive. Nobody's making this work. They need better process. And it turns out that after not that long really investigating, we found out that the problem was not that the process needed to be optimized. The problem was the process, and that what we really needed to do was make things faster and make things cheaper, and that this needed a switch from a batch process to continuous process. And in order to do this, we needed to change some fundamental aspects of how people do biomanufacturing, specifically the organism, and no one was willing to take that risk. And so we decided that, we might as well do it ourselves.
Right. And it's worth noting that part of what makes what we're doing possible is that we're young, we're nimble, we're able to take risk on a level of the technology that incumbents traditionally shy away from. And there's a lot of conventional wisdom, especially related to changing the organism, that we're going against.
And so what principles do you rely on to kind of guide you on this? So you're saying there's a lot of things that you're challenging within conventional wisdom, but you're looking to sort of, reshape the industry, the approach. and do it on principles that are grounded in sustainability. Like, can you tell me, like, where are you finding the kind of good guardrails, the approaches, the principles that you would, set the company down by?
Well, we're really students of history on this one. When we were still in school, there was a big clean tech craze going on, and we've talked to and paid a lot of attention to, read a lot of the articles on the first wave of companies that tried to do stuff like this, essentially brew chemicals, or in that case, brew fuels. And we learned a lot of things related to how a business should be built in this domain. Things like ultimately, you may not want to start in undifferentiated commodities markets where you're selling the same stuff everyone else is. You may want to talk to your customer before you try to sell them something and figure out what exactly do you need. Is it just a molecule you're buying? Is it just a product? Maybe it's how fast we get it to you. Maybe it's the website, the UX, all these other things that traditional entrepreneurs in heavy industry or biotechnology didn't really think about and perhaps missed. And so we really paid attention to the first round of companies, tried talking to those executives, figuring out, okay, beyond the technology, which we could model in a spreadsheet and figure out, okay, this is what we need to do. How could we make a business that was viable around this? And we really believed starting a business was the way to drive a shift in this industry. At the end of the day, we're operating on the scale of billions of pounds of stuff a year. And that's not a logistical problem that anyone in other institutions has to think about or face.
That's great. Yeah. And I want to dig into the kind of like impact of this, if successful, because you're talking about the kind of like difference between efficiency and direction. And Julie Zimmerman, who leads the Center for Green Chemistry and Engineering, talks about this a lot at Yale in terms of like, it doesn't matter if we make things more efficient and we're going faster in the wrong direction if we haven't changed the process in a meaningful way. And so can you talk about like, when you model out and consider what the impact is of a changed direction here, like give folks a sense of the magnitude of what this would mean for communities and what this would mean for ecosystems. Like if this replacement is successful at a meaningful scale, like what does this look like?
You want to start?
Yeah. Well, so I guess really broadly speaking, is it 6% of all carbon emissions comes from the chemicals industry. And of course, almost all of when people talk about pollution, industrial pollutants, much of that derives from the chemical industry in general. And, chemicals are all around us. They're in the plastics, they're in coatings, they're in additives, they're in chelating agents, they're in everything. And we can, I guess, try to decarbonize energy and transportation as much as we can, but this is a real sticking point. It's going to be very hard to change. And I guess the economics of chemical plants too favors real centralization of how the industry is now. So you have these huge plants, things have to be transported there. They have to, undergo dangerous high temperature processes. This has really negative impacts on the ecosystems around and the communities around. It's a big driver of inequality because these plants are not pleasant places. And then you have to transport the chemicals from there. So
to build off on that, Stu, it's not just the carbon costs of the manufacturing process. We don't have to burn fuel to get high temperatures to convert oil to something useful. We don't have to dig into the ground and get oil. We don't have the same kinds of toxic byproducts and toxic waste streams to deal with. Our plants are smaller. It's basically just sugar and water and room temperature chemistry is going on. That has loads of implications, of course, for urban development, where you can put these plants now, whether or not they can be overseas or on shores, whether or not they can be in the middle of a community, where office buildings are today. You could potentially have heavy industries, manufacturing facilities. I mean, the implications there for what workers have to do, for operators have to do, tradespeople have to do. In general, we see ourselves as one in a generation of businesses in this era, I think, where our country has really committed to taking a world-leading position in innovation in manufacturing. And part of that is because it's something that needs to be done for the climate, but part of it is because we have so many issues with urban development and jobs and inequality. And so innovation like this has implications across many different issues.
Can you give folks a sense of just the scale of what you're talking about? Like, what is the size of a chemical manufacturing and production facility today? And what is the size of what you're proposing? And what do those look like? Like, tell me a story and a picture of like when you're looking down in Louisiana and seeing these to like where you could place these. Like, what is the difference here?
So I'm from Texas, and so I've been to Freeport, Pasadena. You can drive down those highways, and you will see these hulking stainless steel infrastructures, which are like marvels of engineering and very, very cool. Centuries worth of the work of very, very talented chemical engineers went into making that stuff happen. And those plants make about 1 billion pounds of stuff a year. Okay, so you could consider for a moment just the logistical challenge of moving 1 billion pounds of stuff somewhere. Our plants, we hope, can be about a 10 to 20th that size, but meet the same capacity requirements. Furthermore, we don't have to deal with the sort of waste discharge kind of permitting, zoning, logistical issues, where you can actually put those kinds of things as traditional manufacturers. So anything else important on that comes to mind? I think those are the big ones.
Great. And so you've got this kind of like elements of transformation of a large industry. And we're talking about, like, as you mentioned, like hundreds of years of expertise that's been built up in this and like lots of lock-in. You mentioned at the outset, you talk with people who you talk with people in the industry and the risk aversion was pretty high toward doing this. Have you connected with or found mentors or people in the industry or who are looking out and who are sort of seeing your idea and saying, I've been waiting for you to come along a little bit, or there are people who are supporting you? Like, what's the response been as you've reached out and kind of talked to folks?
Well, we've definitely found mentors in the chemical space and product development and how to run a business. What we're doing is very new, and so it's kind of hard to explain to people in the chemicals industry this, biotechnology angle, especially when a lot of them have sort of been burned by biofuels stuff in the past. But the big thing that I think people notice and are really interested in is that one of the cores of our technology is we're shifting from current bioprocess, which is typically batched. So you fill up a big tank, you run a batch, you empty it, you clean it, you start over, to a continuous process, which is how petrochemistry works today. And we think is like the essential change in like being able to make biology competitive. And so that really resonates with people. I think that the shift from batch processes to continuous processes introduced a revolution in traditional chemistry, centuries ago. And that has yet to happen in biology.
And so the input to this continuous process right now is sugars, right? So like that's the starting point. Can you like talk to us a little bit about like how you see that starting? What's the best input? Like, what are the implications that you sort of ripple effects you see in the system? And like, are there potentially, ideal inputs that fix other problems in the system that you could imagine or see?
Yeah, Stu, we could talk about, this is probably the single biggest topic of discussion at all hours in the day, which is so-called raw material or feedstock to the whole industry. Oil is great because oil is liquid. The marginal cost of moving a gazillion more barrels of oil down a pipeline is like nothing. You can push oil everywhere you want, and a lot of actors have vested interest in making those pipelines work. A crucial difference with our kinds of inputs that they're solid. The cost of shipping and moving those things around, and this is the kind of analysis which we think a lot of the earlier companies missed, is substantial. And so we have to think really creatively about not just one input that we can use, but a variety of inputs that are available in a variety of geographies, and being able to convert and process all of those. And the closer you can get to a crude input, or a mixed input. Imagine if the oil industry didn't even have to worry about refining. That's a multi-billion-dollar industry itself. So and that would just have a crude input. So the closer and closer you can get just using a variety of crude inputs, the easier it will be to facilitate this paradigm in chemicals manufacturing, which necessarily needs solid inputs versus liquid ones for the most part.
Great.
And ideal, you really got three options when it comes to carbon sources, which are renewable, which are available at the scale of oil. And that's like wood chips, lignocellulose, corn scraps, cellulose, and things like shrimp shells and lobster shells and dead fungi, which is chitin. That's another carbon source people don't think about much, but we certainly do.
Great. Well, you're thinking deeply about all these things and kind of like really getting into the details and geeking out on them. Like when you all decided to kind of apply to the Sustainable Venture Prize, like why did you guys decide to compete? Like, what was the impetus? Like, what was the stage that you were looking at? Like, why was it useful to put in an application and kind of begin pitching, talking about this, raising funds for it?
Well, yeah, generally speaking, there aren't, we couldn't find droves of people looking to start chemicals businesses, especially in college. And the industry is complex. The technicals are quite tough to execute. There's a high barrier to entry. And so for us, and it wasn't just cash to get off the ground. We also wanted to find other people working on these kinds of problems.
Yeah, and so it was not only, it was great exposure for us, but it was a fantastic exercise in putting together rigorous plans and practicing a pitch, which we had given before, but for a much more general audience, and just focusing on presenting our business and like drawing boundaries around what we were talking about.
Yeah,
and it was and we had people who came up to us afterwards and made a lot of useful connections, and so it was very fruitful in that sense as well.
Great. And so as you look to say there's an incoming freshman at Yale, like there's like a new program actually starting where there's 100 students signed up for like one of the Yale summer camps that are all focused on innovation and entrepreneurship, right? And like, so there's a big influx. Like, what advice do you want to give to that freshman coming in to sort of start on this path, like begin thinking about applying to these things, like digging in and really considering this as an approach that they could, invest their time and energy in?
Well, I guess a lot of people, especially at a really early stage, the business idea sort of nucleates around a single idea or technology that is very attractive and that you think will make a big impact. And we found it extremely useful from even a very, very early stage to consider not only the single idea, but the whole like end-to-end picture. So not just here's this big, problem we want to solve, and here's this cool new technology we want to develop, but how can we, while solving this big, global problem, solve our customers' problems, and how can we use this technology to have very specific, applications? And at this point, we're a long ways away from having, customers and defined products, but it's super useful to think about. And one of our advisors, like very early on, told us this quote, which I think he attributed to Eisenhower, saying that he demanded that we write a plan. And then we came in with a plan, and then he like immediately threw it in the garbage and said, "Listen, the plan is nothing. Planning is everything." And so being able to think about it, with a sort of longer lens, even though it may seem distracting at first, we found really helped us to focus on what was important early on, and we had essentially the opposite effect. So
that's an awesome story. And so like this is, one of the things that we've found over time is that a lot of people build solutions in search of problems. And instead, you guys have stayed with a problem that's incredibly multifaceted and complicated and systemic, and trying to figure out the point of leverage. Like that element of that advisor coming in and kind of doing that for you was one. Like, what are the other ways that you have reminded each other or had relied on other people to sort of stay focused on the problem and solving it versus the individual solution that you may have gotten very excited about?
Well, it's tough because you almost get emotionally attached to a certain approach or a certain technology. But at a certain point, and even in the course of the few months of really, really hard work that we've been putting in, it becomes clear that what's most important to this are the people in it. And as long as we keep asking the right questions to the right people, that alone is a huge advantage, and it's the very foundations of a company. So we should be flexible on the technology, on what aspects of the business we prioritize in different times, and be responsive to what customers are ultimately telling us. And I would say looking for that feedback always is probably really important, and being flexible, less emotionally attached to any single tactic that you might have. And at this point, we're off the school of thought where, and just having seen the industry as a whole, it's not just the processes, it's the customer experience, it's the distribution, it's the website they use, do they get it on time, do they like you, do they have a connection with it? It's all these different things. And so we view it as, okay, we have an opportunity now to build 6 or 7 businesses in one, which makes it that much harder for anyone else to do, and it's a lot more exciting for us because we're learning that much more. So
So what are you excited about over the next 6 to 12 months? Like, I mean, what are you going to be doing? Like, what are the kind of day-to-day elements that you're going to be engaged on building? Like what's going to, get you up in the middle of the night scribbling down a new idea, or kind of getting up early in the morning to, make a call, or, write the next part of the plan that you didn't think you had the energy for?
Well, I mean, we're here in our lab. We have lab space sort of over there. This room is a sort of rapid prototyping space where we work on hardware. Our philosophy is to sort of pilot a version, a draft version of our process end to end, even if any one of the steps is like far from being optimized. So we currently have a strain that we've engineered that can produce a first molecule of interest. It's not the best strain, but it does it. We have a reactor that we're not entirely happy with, but that will work. We have a downstream process that is, workable. And so we're going to start, step by step optimizing stages of this process. So with the strain engineering is continuing in the lab. I'm mostly doing that. The downstream process is continuing to improve. Obviously leading a lot of that. We're going to, in this room, soon start building our own reactor, which we hope we can, make it like a first of its kind continuous reactor. And then another upshot of this is once we have this whole process running, even at this small scale, we'll have a very clear idea of like, this is our product, this is how pure it is, the different, levels of purification and processing. And then we can really start to formulate applications for it. And we're probably going to outsource some of that work, but I'd say the product formulation and feedstock are some of the things that we're most excited about.
And those are things which are on opposite. Those are on this end of the value chain. Processes in with the middle, and that's where most engineers come in with ideas. So it really, and reinforce the point that you have to think end to end, because those are the two things which will really lead to long-term defensibility and keep you alive to really optimize everything in the middle. If you're not getting cash, if you're not having customers, if your raw materials are too high because war breaks out or the price of oil shoots up or things completely out of your control, you have to be constantly thinking of ways to protect yourself.
Great. Okay. So somebody, hears this, they're listening to this interview and they say they're getting very excited about this. They're like, these guys are really interesting. They're getting deep into this. They're thinking broadly. They seem incredibly motivated. Who do you need help from? If right now, would you say if these people came and if we had these contacts or connections in the industry or these resources, what do you sort of see as your needs right now? You've got the $25,000 from the Sustainable Venture Prize, you've got a lab, you've got each other. What other things are helpful to have at the moment?
Well, we're pretty confident that we can make our chemical, and we're fairly confident that we can purify it. And then we wind up with, a sack of chemical, and then it's now what? This is the part where our expertise ends. Product development, how to, get in touch with people in industry, the applications there. It's almost never for the applications are almost never for a single chemical. Things get distributed, blended, and packaged for single purpose uses and the ingredients are not always shared. So,
right, and also finding people who are willing to partner with you. And we're a young company. We have we have a long journey ahead of us. But finding an early customer who's willing to say, okay, I'm going to join you in this collective mission. It was a collective goal, and it's not just climate. The country as a whole now is at a point where we're focused on rebuilding an industrial base, and the hope is that American executives eventually have a vested interest in the success of the American middle class. And these are all things which businesses like ours are going to help accelerate. And so finding a first customer, early partner, and so anyone watching this who's any kind of heavy industry, paper and pulp, water treatment, concrete, these are the kinds of people we'd really love to talk to and work with to develop our products.
Great. And when you think about the kind of next round of applicants into the Sustainable Enterprise next year, what do you tell them to kind of get them going, motivated, engaged for the application process, for kind of becoming a part of the entrepreneurial community at Yale, particularly in environmental innovation? And could you also characterize and talk about what is your sense of how the overall community across Yale is supporting climate innovation or environmental innovation? What does it feel like amongst the students and alumni that that are around the university?
Well, it is growing, and it's growing very, very rapidly. And climate is obviously a front rank issue everyone thinks about. I suppose what I would say, and maybe this isn't right, is you should be interested in this, not just because climate is important, because people have been shouting from the rooftops about this for 10 years, and we're finally waking up to it. This is also an amazing learning opportunity and business opportunity for a young for anyone, any technologist. And, in case you're interested in doing something besides mobile apps or, websites, this stuff's pretty cool.
Yeah, it's been great fun, the whole process, and we've gotten to talk to so many interesting people. And one thing I know there's been a big push for climate innovation at Yale too that we're very excited about. We've talked to some people from Climate Haven, and one thing we're particularly excited about is that it's much more in tune with the needs of a company like ours. So we're here in a bio incubator. Most of the companies here are working on medical technology, and there's not a ton of infrastructure for people like us who are building hardware. So this room is an office that we've sort of turned into a hardware lab. But it's very exciting to see support and recognition that biology can be used for things other than medical applications, and having the infrastructure there is huge. So it's a very exciting time.
Yeah, and we're obviously we're very grateful to CBEY and to Yale for not just this contest, but we met each other at Yale and everything. So
cool. No, I mean, we're just incredibly grateful and appreciative that there are bright, talented, persistent folks like yourselves who are taking on incredibly big challenges and doing it in a thoughtful and comprehensive way. And really, glad that you brought up Climate Haven as a space that, for someone who's just won the prize, for a team like yours, and then looking for a next step and spot, that will open in the fall of 2023. And, we'll have at scale 17,000 square feet of office and light industrial space that will then, house 25 companies that will be kind of humming right in downtown New Haven. So I really am thankful that that's a place and an opportunity that you're seeing as a good spot. Any other things that you would want to share or kind of final words? I mean, we're really excited to see where you all are going and how this is going to develop. Do you have anything you'd like to share before we sign off?
Well, always a shameless self-plug. We're always looking for potential customers, partners to help us develop our products in a variety of heavy industry. This is a concern for you. Please reach out to us, and I'm sure we can put our contact somewhere in the description.
Great. Well, thanks so much, and really appreciate you all competing in the 2023 prize. Congratulations on winning, and we're really excited to support you and see where you go next.
Thank you, Stuart.
Thank you so much. This is great.
We appreciate it.